Good evening, everyone. A very warm welcome to all of you. Thank you for joining us for today's session on Sciences at Ashoka. This is an excellent opportunity for you to engage in conversation with Ashoka's stellar science faculty members. Whether you want to explore majors and minors, delve into their innovative work, discuss about their novel research projects, understand teaching methods, or inquire about any other aspect of the Ashoka's undergrad program, this session is tailor-made for you. I'm Yukti and I oversee the academic communication efforts at Ashoka University. Prior to joining Ashoka, I did my PhD from Tata Institute of Fundamental Research, Mumbai. Although Ashoka builds its capabilities based on the undergrad educational requirements, it doesn't compromise on the research capabilities of its faculty members. They are capable enough to work individually or as a team to solve crucial problems in their respective research domains. Joining us today are Ashoka faculty members representing three diverse yet connected majors offered at Ashoka. So let's welcome our speakers for this evening. We have with us Professor Garima Mishra. She's a faculty of physics at Ashoka University and a PhD from BHU. Garima pursued her postdoctoral research at Weizmann Institute of Science, Israel, and subsequently moved to the University of Oxford in the UK. And next up, we have with us Professor Deepak Asthana. He's a faculty of chemistry at Ashoka University and a PhD from JNU Delhi. Deepak received the prestigious JSPS fellowship and pursued his postdoctoral research at Kyushu University, Japan. And last but not the least, we have with us Professor Rama Kondi. She is the faculty of biology at Ashoka University. Rama received her PhD from the National Institute of Immunology in New Delhi, and then subsequently pursued her work at Emory University in Atlanta in the States. And here is how we will be taking today's session forward. All the three faculty members, they will share an insight into their respective departments at the university. And this will be followed by general questions, which we'll take up after all the three sessions. So without further ado, let's get started. I will request Professor Garima Mishra to talk about the offerings of the physics department at Ashoka. On that note, over to you, Garima.
Thank you, Yukti. I'm going to share my slide.
Yeah.
Okay. Is it visible?
Yes, we can just go on the full screen mode.
That's great. Okay, so thank you for the introduction and welcome to all of you who are seeing online, although not visible, but we'll try our best to communicate. Okay, so the first question is like in sciences, why physics? So physics, if you see that it's not like it's whole about a thought process that whatever you see or you can't see in that manner also. So you try to understand, and physics actually seeks the understanding from what is behind anything, like from a small object to a big galaxies or universe. So basically, if we want to describe it, we can simply have a quantum physics, which basically tells you about how the objects which are at the very small level, like electron or atoms, you can go further beyond that, of course. So how they behave. Okay? So here I think the picture is that whatever we see, whatever we explore, it's more like a classical world. But if we go to that realm of the electron and atoms, they really have some counterintuitive behavior. For example, it's saying like that in classical world, if Garima is sitting here, can Garima be at many places? This is not in the classical world, but in quantum world, it can be like that. So a particle can have dual characteristic like wave and particle. And using the quantum physics, many phenomena at the very small scale has been explained. The other branch is condensed matter, it is intermediate scale where our everyday life actually belongs. So for example, we all know from some background with the chemistry that why something, all the things are made up of atoms, and then at the fundamental level, electron, proton, and neutron. Then the question arises that why something behaves like a metal or wood, because fundamental units are same. So what makes these differences? And the condensed matter physics actually answered these questions very well. And at very large scale of galaxies and stars, astrophysics actually explain many of the properties, like what happened after the Big Bang, when everything starts. So these questions actually physics can answer from very small scale to large scale. And at Ashoka, at Ashoka, in the Department of Physics, There are 12 faculty members, and all of them they're actively participating in teaching. And as Yukti mentioned, that we are actively involved in the research. So there are core areas of research like condensed matter physics, quantum field theory, and astrophysics. So we are publishing at the international journals, and we are also actively collaborating outside the India. So the sort of questions we are interested in, they are the target question all over the world. So it's not like just a small. So even if at Ashoka, it's just new, but the target questions of the science, research questions in the science, they are worldwide. So people are interested. We also have some international collaboration at different places. And the as far as the teaching is, okay, so these are some research facilities we have at Ashoka. So here at Ashoka in the physics department, we have a very nice blend of experimentalists and theoreticians. So theoreticians basically use this computational facility. So at Ashoka, we have very high performance computation facilities, which involve many many processors with very high clock speed and RAM also. So it's like a really big computational facility at Ashoka, which we can avail. And for experimentalists, there are many such facilities. We can see that this polarized light microscope and magneto-optical current microscopy. These are really nice facilities which someone can avail. Even our undergraduate students, they are allowed to use these facilities in the different research labs. And in our department, we also have some major grants through DST, which is through startup grants, Axis Bank. And of course, Ashoka helps a lot in our research purposes. So Ashoka always funds our needs for research. And as far as teaching is concerned, so these are the core curriculum of the UG program. So we have the physics core courses. So likewise at every standard central universities or IITs. So there are core courses in physics. So we at Ashoka also offer the core courses, which are classical mechanics, electrodynamics, thermal physics, optics, quantum mechanics, and stat math. Moreover, solid state, that's what I mentioned, the condensed matter physics and the mathematical methods. Of course, the mathematical method is a sort of tool for physics, which really we really need to formulate any problem either at very small scale or intermediate or large scale. So these tools are common in all these aspects. Moreover, what is interesting at Ashoka that the UG program we offered, so there we also offered advanced level of courses. So the purpose of these advanced level of courses are to just equip our students with the recent cutting edge research which is going all around the world. And with these advanced courses, we make sure that with these courses, they can also apply this knowledge in short-term projects. And these core courses are also blend with this laboratory experiment. As I said, that we simply go hand by hand. So we teach theory and simultaneously we provide them facility for experiment so that whatever they learn, they can verify in the experiment and they can be assured that whatever they are seeing, they can describe. So similarly, we have these mathematical physics courses, which is a gateway course for physics. So we need this course. And of course, at the end, we have to mention our brand ambassadors. So these are the physics students which are at different places now. So most of them are doing their higher studies, either masters or PhD at different area, different world class universities like. And also there are some which I should mention that it's not just they are interested in. So there are few people who simply switch their branches. So some of them who started with the physics, they moved to the biology and then they moved to the computer science. So I really appreciate the best part of this Ashoka culture is that it's switching, that you may be trained in one discipline and then you can simply explore other branches too. And here, one of our PhD student, undergraduate students, he recently moved to the Cambridge for their further study. So these are some of the important aspects of physics department, and I'm open to answer any of your question if you have. Thank you, Yukti.
Thank you so much.
Am I fine?
Yeah, thank you so much, Garima.
I'll stop sharing.
We have a lot of questions coming in, but we'll take it after the other two sessions together in the Q&A, during the Q&A.
Sure.
Thank you so much. This was quite insightful. So on that note, I would like to invite Professor Deepak Asthana to share more details about the chemistry department at Ashoka University. Over to you, Deepak.
Hi, Yukti. I'm audible?
Yes, you are audible.
Okay. So hello, everyone, and thanks, Yukti, for a very nice introduction. So I am going to start sharing my screen. Is it shared with everyone?
Yes.
Okay, great.
Thank you.
Okay. In next 5 minutes, I'm going to give a brief introduction about the faculty members of chemistry and some of the unique features about the UG program at our department. So we are the newest department in the science division of Ashoka University. Currently, we have 7 faculty members and 16 PhD scholars working for their doctoral research in department. So as you can see, we are a very research focused, research motivated department. And it's obvious from the thrust areas of research which actually pursued in the department. So in a broad term, we can divide the main research areas of our department in computational, experimental or material chemistry, and the chemical biology. So as a part of computational chemistry, research scholars and UG students also get chance to learn about the drug discovery, doing quantum chemistry, and to learn more about how to make things more sustainable in future. In experimental or material chemistry division, we are actually actively working on development of some catalysts for hydrogen evolution. We know the future is going to be all about hydrogen fuels, hydrogen fuel driven vehicles, and some light harvesting related projects and the catalyst development. In the chemical biology part, some of our faculty members are actively working on development of some medicines, peptide chemistry, biomimetics. So as it's like, we know that chemistry is a bridge between which connects the other branches of sciences. So you must have to have a good understanding about the chemistry so that you can understand the biological system fully. Similarly, in the physics, you do the study. If you're experimentalist, you're always going to need new materials. So how you're going to get new materials, that you can do if you know the chemistry behind that. So yeah. Now, this quote I found on the internet also, otherwise I would have called it mine, that everything is given, everything is written in the books. So it's not the books, it's always the teacher that makes the difference, right? So while designing the UG program for chemistry at Ashoka, it's quite a bit of task, because keep in mind that it's a liberal science and arts university. We need to make sure that the courses are suitable for everyone. If suppose someone from humanities want to do minor in chemistry, then it should be planned in a way that it's not very unsuitable for that student. So you can see from this list here, some of the best professors from chemistry from India, institutes and universities have been involved to design the course structure here. So Professor G. Mukesh from IIT Bangalore, Professor A.K. Singh from IIT Delhi, who is currently the director at IIT Berhampur, Professor C. Subramaniam, Professor Debrat Mathi from IIT Bombay. Debrat Mathi is also, he recently received the Bhatnagar Award, which is the highest award given in India for sciences. Professor Ramakant, Professor Archita Patnaik, Rita Kakkar, and Professor Sasankdi from IIT Delhi. So this makes sure that the structure is very well defined for our UG students. Okay, so now I would like to introduce the faculty members. Professor Saurapal, who is also our HOD at chemistry department, he is a very senior person, and as you can see, he has been a visiting professor at various universities across India and the world. He has been visiting professor at University of Arizona, University of Tehran, Poland, in Japan. He is adjunct professor at IISER Pune and IIT Goa. He has been president of Chemical Research Society of India during 2014 to 17. The list is very long, and he has been awarded the Santi Swarup Bhatnagar Award in 2000. And He had supervised around 45 PhD theses and has written a book on mathematics in chemistry. He's a very well-known theoretical chemist in India. And the second faculty member in our department is Professor Vidya Ausare, who has a huge experience of teaching. So prior to joining Ashoka, she was teaching in Pune, and she has been awarded with the National Teacher Award in 2021 from Indian National Science Academy in Delhi. She has been also featured in a recent magazine, which notifies the 75 women in chemistry from India. She is 75. Among the other faculty members, we have Dr. Munmun Ghosh. Dr. Munmun got her PhD from NCL Pune, and then she worked as an AVH, Alexander von Humboldt Fellow in Göttingen University, Germany. So I must tell that these are very prestigious fellowship awards to get. And she has worked in during her PhD in Germany and in USA, and she joined Ashoka in 2020, and her research work is about electrochemical CO2 reduction, which is a very major problem today, and catalytic hydrogen evolution reactions. Dr. Arya Ghosh, he also did his PhD from NCL Pune, and he has been a visiting researcher at University of Edinburgh, UK. Then he did a postdoctoral work at Germany, and then he joined Ashoka in 2021. This is me again. So yeah, you already introduced me. I got JSPS fellowship to work in Japan. So 2014 to 16, I was in QC University as JSPS fellow. And then I moved to UK. So 2016 to 2021, prior to joining Ashoka University, I was working in the School of Chemistry, University of Manchester, UK. And my research field is about designing and synthesizing new molecular materials for light harvesting and optoelectronic applications. These are the two new members who have recently joined our department. Dr. Saurabh Chatterjee, he is PhD from Indian Institute of Chemical Biology, IICB, Kolkata, which is a CSIR lab. He did his postdoctoral research at the Scripps Research Institute, Florida, and another postdoc from University of Minnesota. And his research fields are in the field of enzyme kinetics, medicinal chemistry, and chemical biology in wider terms. Dr. Santu has joined our department. Most recently, he is working as a faculty fellow. He got his PhD from IISER, Kolkata, and he has done, he was awarded with Marie Curie Fellowship, which is a very prestigious fellowship, which you can apply for to work in European countries. And he returned to India with Ramalinga Swami Re-Entry Fellowship, and he also has been awarded with Ramanujan Fellowship. And his research is about synthesis of peptides. So yeah, if you join Ashoka, if you come here and if you take chemistry courses, what are the opportunities that you can get here? So in our department, we strongly encourage UG students to take on projects, to work on the active projects. So you can work along the PhD students and actually learn about the research-based topics, the new things. You know, whatever is written in books has, if you have any question, you can find the answer in the book. But if you want to do something new, if you have a question about something which doesn't exist, then that's the part of research. So you can learn these topics, which are futuristic in science terminology. You can learn about the various analytical methods of characterization, such as suppose if you have found something which you don't know, which doesn't match with anything existing, then the set of experiments which you can do to know more about it. You can also take on the independent research projects, and if possible, if you do a good job, it could be published and you can get a publication during your UG study itself. So all this been designed to provide you with experience so that you can do anything in future in a very interdisciplinary manner. So theoretical or experimental topics like quantum chemistry, drug designing, medicinal chemistry, this you can extend to the physics or biology, or you stay in chemical research. Actually, there is no in today's world, there are no boundaries about science. These are some of the pics from our recent Chem Society event, in which we took our students to a nearby IIT instrument facility and gave them, they got introduced about some of these very, very high-tech instruments. So these are the regular activity in our department. And, chemistry is like opens up all the opportunities. If, for example, forensic science, it cannot be there without the help of chemistry. Development of new materials, designing new systems, development of new vaccines, or development of new medicines, everything you have to have some sort of knowledge of chemistry. Okay, so with this, I would like to stop here, and we'll be very happy to answer any questions you might have.
Thank you so much. Thank you so much, Deepak. We have questions. Again, we'll take them up after Rama's session. So on that note, I would like to invite Professor Rama Akondi, and I would request her to shed some light on the offerings of the biology department at Ashoka University. Over to you, Rama.
Oh, all right. Thank you, Yukti. Am I audible?
Yes, you're audible.
Yes.
Yeah.
All right.
Thanks.
Okay, so I will just make a note of the time. Yukti, can I please request you to let me know in case I go over time?
Sure,
when there's the minute left, I'll wrap up. All right.
Sure.
Thank you. All right. So I'd like to start with explaining the statement that I made, that we take a very broad view of biology at Ashoka University. And I'm going to just start by stating all the systems we use to study biology and ask biological questions. These include Drosophila, which is a common fruit fly. You know what happens when you leave out a banana peel outside, the small flies you get. That's a great model system. Bats, bees, wasps, bacteria, phytoplankton, crickets, plants, forests, roundworms, beetles. And of course, mine is focused on humans. And what are the kind of questions we are answering using these systems? We are answering questions to do with plant-animal interactions. For instance, plant-pollinator interactions. What happens to plants and their plants during drought? Glycobiology, human immune memory, which is again my area of interest, genetics and evolution, cell biology, evolutionary immunology, G protein coupled receptors, which are a class of receptors that contain a lot of the cancer targets, antimicrobial resistance, which is a topic that has been even in the news a lot, mitochondrial structure and function. I think you get the general idea. The reason for mentioning all these topics and not my colleagues is because it's my colleagues' areas of interest, and we're about 18 to 20 faculty. So instead of mentioning their names, we're all very hardworking. We all have great experience. You can look at it at the Trivedi School of Biosciences Department of Biology website. I thought I would mention the kind of view we take of biology. So I hope I've convinced you that we are not limited by the system, and the questions that we're asking are very diverse. And coming to interdisciplinary research, which both my colleagues mentioned, I'm just going to select just 2 examples of the ongoing research that my colleagues are carrying out. The first one is to do with circadian rhythms. Circadian rhythms are essentially, a circadian rhythm is a 24-hour internal clock in our brain that regulates cycles of alertness and sleepiness by responding to light changes in our environment. And you can imagine that this is very hard to study in different systems, and this also has important implications even for human health. So my colleague, I find this work very, very interesting. This is my colleague, Dr. Saugata Roy. And his interest, the area is called chronobiology. And what he does, he uses a model organism, a unicellular organism called phytoplanktons, to ask different questions about circadian rhythms. You can look more on his website. He also has a Twitter account if you want to learn more. But the important thing to note here is that he's asking a very broad biological question using a very simple and addressable system. So he's broken down a complex question to a very simple organism. And it's been noted. Now, my interest is that I never used to think about these things before I joined Ashoka University. But since then, I've started paying attention. There are papers that say that even vaccine responses, which is my interest, vaccine responses are impacted by circadian rhythms. And the next example I'll highlight is also equally interesting. It's jumping to something very annoying, which is wasps. Okay, and the title here says ordering topological detects in social wasps' nests. But to break it down very simply, my colleague Shivani, the question that she asked is, how do wasps make nests? Now, it's known that those nests, if you've seen them, they're actually an architectural marvel. Okay, they all have these hexagons. I hope you can see them on the screen. That's a real picture of a wasp. And hexagons, because that's the most efficient way to fit them together. Okay, and this is the schematic of a perfectly formed nest. This is one where it's kind of misformed, and sometimes wasps will leave these misformed nests. And so Shivani actually looked at the physics behind the material that they use. Wasps use a different material than bees to make their nests. So Shivani asked some of these questions. Now, here's the interesting bit. So this resulted in a very nice paper in a high-impact journal called Science Reports. And this is a collaboration between Shaumin Bhattacharjee, a senior scientist in physics, and between Shivani. And so how this came about was, it was just curiosity-driven research. So this is what she says in one of the articles. Polistes wasps are actually just paper wasps. That's the species name. Polistes wasps nesting in large numbers on the Ashoka University campus allowed us to address questions such as regularity in hexagons and how the wasps were arranging them in a natural environment. So essentially, this was during the COVID-19 pandemic, because otherwise, wasp nests for safety reasons, they'd have been removed. The campus was empty, and then Shivani just noticed she'd record these videos of wasps' nests somewhere, and that resulted in a very nice finding. And of course, it helped that physics professor, they both collaborated, and that's a very nice example of interdisciplinary research right there. And coming on to a much very different question and system, my interest is in vaccines. And to put it very briefly, what I'm interested in is that how vaccines protect. So till date, most of the successful vaccines have been, I'm going to say, guesswork. Okay, when I mean successful, I mean they provide lifelong protection. Now, of course, we know how to make vaccines, how to design vaccines, but there are gaps in knowledge about predicting. So here's a vaccine, it elicits an immune response, and ideally it should elicit protection so that upon exposure or infection to the disease, exposure or infection to the pathogen, there is no disease, right? But we know that there's a spectrum. Protection is not always absolute. And so the question that I have in mind is how can we find correlative predictive markers that will answer whether the vaccine protects and to what extent, right? And my specific cell type of interest is what are called cytotoxic T lymphocytes. So mostly it's in the area of antiviral immunity. All right, so that's about research, but how does all this research impact teaching? And I will make 2 points. The first point is that one, of course, as I think Deepak also mentioned, we like having undergraduates in the lab, so it provides internship opportunities to work in an academic research environment and just learn through absorbing, working in a lab with PhD students, with master's students, attending lab meetings and everything. The second thing is it does impact my classroom teaching. So when I teach in a classroom, and this is true of all my colleagues, we don't limit ourselves to textbooks. Textbooks are great for immediate knowledge, for basic knowledge and structured knowledge. But just remember that a textbook, by the time it's written and published, it is outdated by about 10 or even 15 years, right? So we kind of do our teaching based, so our research impacts the teaching. So a simple example is the recent Nobel Prize in Physiology or Medicine recently. I was very excited about it. It's to do with the vaccine. So I introduced that topic into the immunology course I'm teaching. And other examples are my colleagues in the in biology who do ecology and evolution space research. They they structure very nice lab courses. One of them is called, which all undergraduates, it's compulsory for all undergraduates. It's called Life in a Neighborhood. So sometimes you'll see students picking spiders or observing behavior of bees and all that, taking walks outside campus. And so this is not textbook teaching, and it's driven by my colleagues' experience in research. And all right, so those are the 2 points I'll make. And the final thing is, I think about teaching, I'd also like to say is that the focus is on curiosity-driven questions and understanding. So instead of giving students these big experiments, which they will just they will just kind of be stressed by, we focus on, encouraging them to ask questions in class. We focus on fundamentals. So for instance, the first biology lab that I took, we just taught students how to pipette properly, what are errors, how to judge if a pipette is working, and so on, right? And I'd also like to endorse everything my colleagues said. I'm not repeating that, but the same things that Garima and Deepak said for the chemistry and biology, chemistry and physics courses, which is there are introductory courses in biology, there are gateway courses, and that set up students for multidisciplinary research. And then we have people who engage in course design. Course design is not static, it's dynamic. So which means semester to semester, year to year, we do revise it, and we make sure it meets student needs. All right. All right, I'll just take one look at my notes here. All right, yeah, okay. So that's what I wanted to say about teaching. And I'll just say that teaching at Ashoka and the Ashoka students, well, I'm the instructor and the teacher, but I learn a lot from them and their questions. The last thing I'd like to say is that I talked about diversity in life. I think teaching here taught me that we just don't have diversity, not just in research, but in the classroom as well. So sometimes we have Office of Learning Support who lets us know their students with specific learning needs. So learning needs, sometimes there are challenges, there's ADHD, or sometimes students will have, it's called, I came to know of dysgraphia once, which was mentioned in one of the workshops. They have trouble writing. So then we make sure that we embrace all these diverse students and we try and meet their learning needs. And apart from that, if you come to the campus, you will see that there is a lot of diversity. Science is for everyone, regardless of age or gender or sexuality. And you will see that on campus. So it's a truly, there is true diversity in life, not just in research. I will end my talk with that. And Yukti, this is on to you.
Thank you so much, Rama. I think you covered a lot of ground in this short span of time. So thank you so much. I will also request Garima and Deepak to turn on their cameras, and then we'll subsequently start taking up questions as we have a lot of questions lined up. So, all right. So I'll start with physics. The first question is a student asking, what astronomy and astrophysics facilities does Ashoka offer? And as a person has a keen interest in astrophysics research, and he's wondering if Ashoka would be a suitable choice for pursuing this field. Garima.
Yes. So I couldn't detail you about the faculty member, but if you see the current faculty member at Ashoka, So it's very nice blend. So there are many astrophysicists, and they too are from like top institutions. So we have like blends, like a senior people and some young people. So if you see the background, if you can do a small search, all these people are very well established in their field. Okay. So like Kandaswamy Subramaniam. So he is from Ayuga, and the courses. So these people are actually sort of starting like pillar when the Ayuka was established. And probably if you're interested in the astrophysics, you might know that this is a very good center for astrophysics and astronomy. So in that sense that, and there are, of course, so recently, I think this year itself, we started a astrophysics minor. So we are also offering many astrophysics courses like competition in astrophysics, and also that there is something called astrobiology we are offering. So there are many short courses, like elective courses for our students. And I believe that they are like the main thing is actually in Ashoka. So we give the minor degree in Ashoka, which is open for all the students. And our faculty members are doing very cutting edge research in the astrophysics. So you can see the published paper from them very quickly from the Google Scholar or see whatever you can use. So in that sense, I think it's a really nice platform to start at Ashoka, to choose Ashoka if you want to do the astrophysics and astronomy. So half of our faculty is from astrophysics. Okay. I hope that's sort of
Sure.
I
Thank you.
answered the question.
Yeah. I think you answered it very well, Garima. So the next question is from chemistry. We'll take this up. So Deepak, someone is asking if a student who has not studied chemistry in class 11 and 12, can they take up chemistry as a minor?
Yeah, they can. We have had in past students who did not have studied chemistry at the 12th level. So they can, of course, do a minor in that. That is why the second semester courses, when students start taking subjects, first semester is foundation, second semester they come to the subject-wise classes. So it's been designed to give, it's a very good blend of topics for kind of a revision to those who have studied in their 12th and high school. And for those who have not, they can also learn with them. So yes, it is possible. Okay.
Thank you, Deepak. Then Rama, this question is for you. What minor is crucial with the biology as a major if one wants to pursue a career in research?
That's an interesting question. So first off, keep an open mind, because Ashoka offers the opportunity for you to kind of explore and change your mind. Okay. But I would say that that's an interesting question because there is no mandatory minor that you need to take, right? I'll give you examples. There are students who are minoring in anthropology, in political science. The anthropology bit comes in. So their major is biology. And I must tell you that they are very good students. It's not that they're confused. They have a very specific goal in mind. And these are final year students. So they are interested in policy. So political science and anthropology comes in two ways. One is policy making, vaccine. Who gets the vaccine first? How do you judge a vaccine, how it affects populations, and so on. And you can see my discomfort in talking about this because I didn't have the option of minoring in anthropology or political science. The anthropology also comes in from, say, how do you communicate with people? Vaccine hesitancy is a thing, so how do you know about populations, communities, and how do you communicate with them about vaccines, right? So it depends on, so it's whatever you want to do. There is no absolute necessary minor needed if you want a career in research, right? Research is a very broad term, and you can be a scientist who works on policy, who can be a scientist who also indulges in science communication. So I hope that answers your question.
Thank you so much, Rama. So, Garima, the next question is for you. So if you could provide some insights. Okay, by the way, before I ask this question, sorry to interrupt. A lot of the attendees are asking if the recording of this webinar will be available. Yes, it will be available on the Ashoka's YouTube channel. So please feel free to share it with your friends, family members, colleagues, whomsoever would need it. So yes, the recording will be available. On that note, coming back to the question, so Garima, if you could provide some insights into the flexibility of the curriculum at Ashoka in accommodating interdisciplinary pursuits. So if you could just shed some light on that.
Okay, so I think this is perfect. This is a perfect question for me because I being a physicist, I started with this physics. It's all over. And by the end of my master's, I came to know that, okay, there could be something the physics and biology can come together. It's really late. It was like once I started PhD that time. But at Ashoka, these things are like, I think this is just in play. It's given to you that you can anytime choose. Like there is no restriction that if you're simply doing physics and physics is just like some equation solving mathematics. No, it's not that. It's effectively that we always have this biology people in the biology. So we actually ask the questions that, okay, these questions, what we are asking, can you tell us the real biological system, what those are? And my research field is actually these protein and DNA. So basically, I didn't know anything about it. And at Ashoka, if you start as an undergraduate student, in that case, these flexibility is always there. So you can come in, and that is also like true that you can have physics and all the background. You can also do the astrophysics. You can go there, and the biology, astrobiology, like I mentioned, that astrobiology. So there's like you can also explore that whether there is life at other planets or not. So whether some biological signatures there or not. So if you are taking physics, we are also open in that sense that you can have the multidisciplinary research because we are giving all the physical tool we are providing. With that, we are not biased with the question. The questions are open. So you can come up with any question, and with a set of tools we provided, you can answer that. So in that sense, at our department, we are really multidisciplinary. So most of us are also doing this biological stuff with the physics. So in that sense, yes, it's effectively it's multidisciplinary subject, and Ashoka gives you this freedom to switch in. That is really a nice thing about Ashoka.
Sure. Thank you, Garima. So Deepak, if you could take up the next question and talk about the different career opportunities that exist after completing the undergrad program with the chemistry major from Ashoka University.
Well, like the approach here, what all the departments in Ashoka have is to provide you a very interdisciplinary kind of development in your studies. So all the branches for you will be open. If you want to enter, if you do chemistry major, but you want to enter into the biology, you can take that. Or if you want to take a break, if you want to have a job right after your bachelor's, you can, because studying chemistry gives you that opportunity. For example, there was a student last year in our department. She wanted to work in cosmetics industry. So she finished her bachelor's here, and then she took a specialized master's in Australia for something which suits to her requirement. So you can, if you want to immediately take a job, or if you want to have a startup, everything will be open to you. So yeah, I mean, you can become, you can have your own startups based on, for example, some of the students, they recently came up with an idea to have this, the recharging platform for electric vehicles. So you get to know about batteries, you get to know the chemistry behind the batteries. And if you're interested in these days, you know, it's a kind of a revolution about the electricity driven vehicles. So starting from higher studies to having starting new startups or industry or going for a job, everything is open to you.
Yeah. Sure, thank you. All right, Rama, if you could take this question up, for a student with a strong enthusiasm in environmental science, which undergrad major would be more suitable for her to choose?
Okay, the major would be environmental sciences. I didn't mention my environmental science colleagues just because of lack of time and so on. But it's a good department. In fact, I think you can check out the department website. But yeah, you can. There is a major. I think they have cross-listed courses and everything. But you can major in environmental sciences. But you know, I do have to check if it comes under a biology. I'm pretty sure you can major in environmental sciences. But if you want to know more about the department, I suggest Yukti. I think the talk is available online, scientifically
Yes.
speaking. So
Yes.
my colleague Manvi Sharma from Environmental Sciences, she gave a talk titled "Fantastic Beasts and Where to Find Them." So you might want to listen to that. You know, just to get a. Otherwise, there's Meghna Agarwala, Divya Karnad, Mahesh Rajan, very nice department.
Thank you, Rama. So someone is asking about the status of the Trivedi School of Biosciences. Yes, it has started. It started about 3 years back, and the building is under construction, and I think it will be up by early next year. Please correct me if I'm wrong, Rama. And biology department is also a part of Trivedi School of Biosciences. All right. On that note, we move on to our next question, which needs to be addressed by Garima. Is it advisable to double major in physics and computer science? Has it been done by students in the past? And what are the advantages of studying physics and computer science simultaneously?
Okay. Okay. So to the best of my knowledge, till I think last year before this NEP came, so this double major was not available for our students, and the reason was that the course credit required, the total course credit required, that couldn't be computed in 3-year degree. So you can do, but not like full-fledged double major what UGC recognized. Okay, and but now with the NEP, I think this possibility definitely there, because in 4th year you can have the scope to do this computer science. You can have the more courses which can actually give you the double major degree. But to the best of my knowledge, I don't think that anyone got this. But interestingly, that most of I can definitely tell that this flexibility, this moving from physics to computer science is more obvious to us, because so if you are not, suppose you don't want to go in the higher academia, and if you want to do, so that flexibility, because this computer science major is minor is always be there. So you be physics major, minor in the computer science, and that helps you to go in data sciences and all these designing AI. So these things are open, but double major, I don't think that so far someone got. But hopefully now onwards with NEP we have a lot of luxury, so we can have it. We can see it.
Thank
Okay.
you. Thanks, Garima. Deepak, the next question is for you. If you could talk about little about the semester exchange program that exists, as it has been mentioned on the website that undergraduate students at Ashoka, they have an opportunity to spend a summer or a semester abroad in partnering universities. If you could just shed some light on some of the examples.
Yeah, that's actually a great opportunity for UG students, because Ashoka had signed MOU with several universities from Europe, US, and other Asian countries like Singapore, and yeah, but definitely with Singapore, I know. So time to time, there are such exchange programs when the UG students from Ashoka could be sent there for either for summer break, summer research, or maybe for entire semester. So those opportunities are there, and I do not have an example from chemistry because we are really new. But I remember one incident when there was one such proposal to send students to Singapore. So Singapore team was visiting, and then we had conversation with them. We have very active MOU with Groningen in Netherlands, which happened last year. So through that, of course, UG students who are interested in going abroad for their, mostly we plan to do that during their active semester breaks so that their regular studies are not affected. It could be easily done. Yes.
Thanks. All right. Rama, is a student is currently pursuing, I believe, class 12 through an IB board, and that student has biology, but is curious to know if he or she can take up chemistry as one of the courses if the person gets to join Ashoka.
Actually, yes. See, the thing is, we have the Ashoka undergraduate program has what are called foundation courses, which are 9 mandatory courses. One of the foundation courses is Principles of Science. And it's not just one course. You can pick among which faculty is doing Principles of Science. For instance, Professor Alok Bhattacharya does a more biology focused course. Professor Shaurav Pal, the head of the department in chemistry, does a more chemistry focused one. And actually, I attended one of his lectures, which is great. So even if you don't have a chemistry background, that will give you a start, a good start. And then, of course, all the faculty here, we all have office hours. If you need some catch up, we are always here to talk to you. If you're talking about minoring in chemistry, majoring in biology and minoring in chemistry, I'm sure that's possible. I'm a little bit not aware of the combinations all the students take. I usually rely on our undergraduate coordinator for these questions. I'm sorry, I can't tell you how many people have done it and so on, but it is certainly possible to minor in chemistry. Or even if you don't minor, certainly possible to audit courses and so on. A lot of professors don't mind you auditing the course.
Sure.
If you want to learn chemistry.
Yeah, thanks, Rama. I think there is another question pertaining to biology, if you could take that up. So a person wants to know if he or she would like to pursue a career as a biology educator. So what would be the best minor the student can choose?
All right. So I must say that the question makes me very happy because biology education, science education is very much needed, and as I think Aristotle is the one who said that, I don't know the exact words, but those who can do it, but those who understand teach. So I think that's a very, very good goal. I appreciate you for that. But here's the thing: what kind of a minor should you take? I would say a minor in maybe let's see, depending on your strengths. Okay, so I think so it's not just about learning biology, it's about pedagogy and how to teach. So yeah, Ashoka has programs such as, so this is again part of your fundamental, your foundation courses, which is critical thinking and analysis and so on. I think that is important when you teach. But the minor I would take, probably I'd pick chemistry as a minor, because a lot of things when you teach biology, they are a little bit chemistry oriented, how proteins function, structure function relationship. So my first suggestion would be that you can take a minor in chemistry. It will help you understand biology better. The second suggestion would be, so suppose for me, suppose my weakness is communicating in general, communicating briefly or communicating in English, then I would make use of the CWC, the Center for Writing and Communication. How to communicate. There's a workshop coming up on Tuesday on popular science writing. That just kind of helps you hone your communication skills, which is very important when you teach students. You need to get them interested. You can't just, you can't just blurt out what is there in a textbook. So I think these things will help you. I hope that answers your question.
Sure. Thanks, Rama. All right. The next question is again on interdisciplinarity. Garima, if you could take this up. The question is, it is hard to imagine studying core sciences in depth along with other subjects in interdisciplinary courses. And if the person wants to know how rigorous the academics get and how many hours per week are required from a student to manage the two subjects, like two different disciplines at the same time.
This is something I think means okay. So you see, I can't say that it's just like very easy. Okay, but easy is like, it's relative, like what you say easy. That if you are really if you like the subject. Here I want to mention again the good part of Ashoka. So usually what happens, that if you don't like, you have option to leave the subject. Okay, you can simply switch in. So if suppose you came for physics, it's supposed to be hard I think to most of you who didn't like physics, the reason is because mathematics is too hard. Okay, so I agree that this is hard, but in other institutions, like if you go to any central universities, IITs, anywhere, if you join, then this change is not allowed. And with Ashoka, I think that the possibility that you can explore first. So there is no bound, that you never come as a physics or biology, or for that matter, liberal arts. So they don't tag you in the beginning. They simply consider you that you are a beginner. They start with the foundation courses and they give you one by one that these are the topics you have to consider. These are the courses you can take. For that also you get suggestions. And then you can slowly see that whether you can get the interest. So I can tell you one of my experience with physics, at least. So there was a girl, she didn't have maths in the 12th class. Okay, so she simply came, and as we are telling everybody that we don't bias. So if you don't have, Ashoka provide the basic it fulfills the basic requirement of let us say for physics. So this girl came as a without mathematics, but then what happened, that she really liked the subject. She learned the mathematics, and right now she's doing, so we know her status, she's doing PhD in astrophysics, which is really hard. So the point I'm trying to make, that it's not that how much time you will give. So don't think as a burden. It's simply like if you start, so you think that you start liking, so you will start reading novel. Why you complete the novel? You complete the novel because you like the subject, you really enjoy it. So if you get this sense of like enjoyment, then I don't think you'll bother about time. Okay, so the time will only come when you start like it's a burden, you can't continue. So I can assure that this luxury you can definitely get in Ashoka, that where you can simply come, start choosing, and if you like, you continue. If not, then okay, then there are other options. You can simply take that there are options like major, minor, or concentration in that subject. So that's perfectly fine. So this option you will definitely get, and you can start with.
Thank you, Garima. Rama, would you like to add to that?
Yes, if that's okay. Yeah, okay. Yeah. See, the one thing is, for anything in life, there are no shortcuts. You do have to work hard. Okay, I endorse what Garima said completely, but you do have to work hard. But the point is, you just pick what you like, so that hard work doesn't seem like hard work. That is one thing. That said, all of us are speaking from an instructor point of view. We all have gone through our student phase, where probably we face the same things. Arey, itna difficult hai. Arey, itne sare subjects hai, right? And then among the students also, I see that we have, like if there was one class last week, the whole class, I mean, my class was all very, not interactive, not paying attention, because they had a bunch of assignments, exams, and so on. So that stress is there. Right? But that will be there anywhere, frankly. It's the one thing I like at Ashoka. I'll tell you two things, okay? First off is all the faculty are told about the Ashoka Center for Wellbeing. So wherever we find students in office hours or something, if they're in some kind of distress, I always tell my students that focus on the learning. I know it's easy for me to say, but honestly speaking, I say it again and again. In the long term, it's learning that will help you, not grades. Right? And if there's a student who's facing distress, I'm not a trained professional, right? But there is a center for well-being. I encourage them to go and speak to counselors there. And the nice thing is, students will sometimes, it's not something of shame now or something a secret now. Students will say, well, Professor, can we, have office hours at another time? I have a session with the Center for Wellbeing. I find that so nice to manage that stress. Things will get stressful. Of course, it's not easy. You're going to graduate. People who join will graduate with a good degree. They'll feel good about it. They would have learned something. And yes, there'll be stressful moments. There'll be moments where you say, oh my God, ye kya ho raha hai? Right? So there's counseling at two levels. One is our undergraduate counselor is very good. She tells students, okay, if there's an enthusiastic student saying, I'll take 8 courses this semester, they'll be like, no, 8 is too much, and this is how you do it. That is one thing I'd say, Center for Wellbeing. The other thing is, from what I see around me, there are a lot of clubs, there is a lot of student support, students indulge in, other, whatever their pursuits are, clubs, activities, and so on. I mean, that's what I have seen, which I think is part of learning and can be de-stressing. And there's a student rep, there's separate student groups about course evaluations or how to manage your courses and everything. I think that will be helpful. So that's what I wanted to add.
Thank you, Rama, and thank you so much, Garima. Both of you articulated this really well. So I think in the interest of time, we'll just take one last question and then we'll end with a few announcements. Deepak, if you could just briefly talk about the extent of undergraduate students doing research, and it would be great if you also talk about ASP and if the program is still in effect, and what are the research opportunities available during ASP.
Yeah, so ASP, Ashoka Scholar Program, which was in place until now. So that you continue your 4th year of studies here at Ashoka, and then you get chance to do some theory courses along with a completely research-based project. So, but with the adoption of NEP, which Ashoka is also going to adopt, that you can do as a part of your 4th year bachelor's study. So with this new NEP, you can leave with a bachelor degree after 3rd year of your studies, or you can stay and do you do one more year of studies and you get an honors degree in bachelor's, or you do a research-based 1-year study and then you get a bachelor's with research, 4-year bachelor's with a research program. So that's where actually you have this unique opportunity of being in Ashoka, because here with the level of faculty members and everyone involved in very active research, you can actually work on some very relevant topics, and you can participate in PhD level research work actually. So you get to learn directly from them. It's not like just a part-time being part of some project and you only get to learn how to check literature and what are publications. Here, actually, you can contribute to them. So that's a very good opportunity. And I would really encourage everyone to do that, because then you also become eligible to directly apply for PhD programs. And number of foreign universities accept that. And soon it will be accepted everywhere. So that's something, the very good point actually about this new NEP suggestions. Yeah.
Sure. Thank you. Thank you so much, Deepak. I think one last question is about the application process, and the person is writing class 12 board exams in 2024 and is asking when is the application, when will the application process start? So I can take this up. I think so the applications are open right now. Round 1 of application process is open, and the deadline for that is 22nd of November. And I think my colleague has also shared the link in the chat box, so please feel free to click on that and follow the process, because applications have already started flowing in. So this is a great opportunity for you to explore. On that note, I think I would like to thank all the 3 faculty members. Thank you, Rama, Deepak, and Garima for joining us today. I have a few announcements to make, and after that I'll end. So please feel free to exit if I'm sure you have your schedules ahead of this ready. So thank you so much for joining us today.
Thank you, Yukti.
Thanks,
Yukti. I would also like to leave.
Sure. Thank you. Thanks so much, everyone. So I think thank you for joining us for the panel discussion. Please, I would request the audience members to please take a minute to share your valuable feedback with us. The link to the feedback form is available in the chat box. And kindly note that the recording of this session will be housed on the Ashoka's YouTube channel. So you can share it with anyone who may need it. I would like to also inform our audience that Ashoka University has open houses on the undergraduate undergraduate program across cities tomorrow and day after tomorrow, that is on the 4th and the 5th of November. The registration link for the same is in the chat box. In case you are not able to attend the open houses in person, we also have a virtual open house scheduled for Friday, which is 10th of November from 6 to 7:15 p.m. IST. You can register for the same from the link provided to you in the chat box. And I would once again like to remind our audience that round 1 admissions to Ashoka's undergraduate program are now open. You can apply without your class 12 board marks to secure your admission. And again, the link to the application form is available in the chat box. And if you have any further queries, please feel free to write to us at ugapply@ashoka.edu.in, or you can also contact us on the number given on the screen. And this brings us to the end of this session. Please take care and stay safe.